Hello everyone, good evening. This is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering, Coimbatore. So in the last video we discussed about segmentation methods, that is isolated points, that is point detection, edge detection and line detection. So in this video we are going to say about region based segmentation, region growing, splitting and merging. So region based segmentation is a technique in image processing where the image is divided into regions based on specific criteria such as similarity in intensity, color or textures. So the main objective is to group the picture into larger, more meaningful structures, making it easier to analyze and interpret the image. So this technique can be useful for applications like medical imaging, object recognition and scene understanding. So let us discuss with region growing. So this region growing, this method starts with a seed of points and grows regions by appending neighboring pixels that have similar properties such as intensity or color. So this process continues until no more pixels can be added to the region based on the chosen criteria. So, example, in a medical image, a region might correspond to a specific organ or tumor. In a satellite image, regions could represent that is different types of land, example forest, water, urban areas. So, in a facial recognition system, regions may be used to isolate and analyze the eyes, mouths and other facial features. So, the region growing, so for example, tumor detection in a CT scan. So, suppose the doctors need to isolate and analyze a brain tumor from a CT scan to measure its size, shape and volume. This is crucial for diagnosis, treatment planning and monitoring. So, the basic steps for region growing are: first we have to select a seed point, and in this a doctor or a system automatically selects a pixel in the center of the tumor based on the prior knowledge or a rough manual identification. So this pixel is the seed for the region growing process. And the second step is the doctor has to set similarity criteria. So the algorithm defines the similarity criteria such as intensity or texture that the neighboring pixels must meet to be considered part of the tumor. Example, pixels with intensity values with a certain range indicating the tumor tissue. And the third step is grow the region. So the algorithm starts from the seed point and expands by adding neighboring pixels that meet the predefined similarity criteria. It continues this process adding adjacent pixels as long as they are similar to the seed point and the pixel already in the region. And so after connecting all these points, the growth stops when no more neighboring pixels meet the criteria, so forming a segmented region representing the tumor. And the final stage is visualize and analyze. The segmented tumor is highlighted and its volume, shape and boundaries are calculated. So doctors can then use this information for diagnosis or treatment planning. Next we will move on to region splitting and merging. So splitting, the image is recursively divided into smaller regions until each region becomes homogeneous according to some predefined criteria. So merging means small adjacent regions with similar properties can be are merged to form larger regions. So splitting usually starts with the entire image treated as one large region. If a region is non-homogeneous, it is subdivided into 4 quadrants. This process continues until all the regions are homogeneous or reach a minimum size. So in this figure, there are 4 regions. That is the total image is considered as a large, considered as an entire image. So in this, no homogeneous is present. So the total images is divided into 4 quadrants, that is R1, R2, R3, and again we are taking the region R4, and again it is considered as a entire image large region, and it is again subdivided into or A1 or A2 or A3 or A4. So merging, after this splitting process, adjacent regions that are similar or merged into to form a larger regions. Example for region splitting and merging. So we can take land use classification in satellite image. So a government agency needs to classify various types of land usage from a satellite image to monitor deforestation, urban expansion and water levels. So the landscape consists of forest, urban areas, water bodies and agriculture fields, etc. So the main solution is, first it has to initial splitting. So the algorithm starts by treating the entire satellite image as a singular large region. It checks whether the region is homogeneous based on the predefined criteria. In a satellite image, regions representing water, forest or urban areas will have different color or intensity characteristics. If the entire image is not homogeneous, that is, which is typically won't be due to multiple land types, the algorithm split into 4 quadrants. Another and recursive splitting. So each of these quadrants is checked again for homogeneity. For example, a quadrant containing both a forest and a water body will still be non-homogeneous and will be split again into smaller subregions. So this process continues recursively with each non-homogeneous region being split into smaller regions until each region is homogeneous. So merging adjacent regions, the next step is merging adjacent regions. After the splitting process, the algorithm checks adjacent regions to see if they can be merged. So for instance, two neighboring regions that both represent the same forest can be merged back together because they share similar properties. So this prevents over segmentation where the algorithm may have split regions more than unnecessary. So merging ensures the similar land types and grouped together, improving the clarity of the segmentation. So hope this video will help you to understand the basics of region based segmentation. So in this video we have studied region splitting, region growing and region merging. Thank you.